ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation h of t. When does the ball reach the maximum height? What is the maximum height of the ball? And when does the ball hit the ground? Well, let's think about what's going on here. Sorry about the blurriness. There you go. So in this problem, we are given h of t. Remember, h represents your height, and t in this function represents your time. And since it's in 80 feet per second, we know that time is in seconds, and we also know that height is in feet. So all of this information is really helpful for when we start answering the questions. We also know that this is quadratic, which makes a parabola. The leading coefficient is negative, so it does this shape, right? And you can think about that as well. If you throw a ball upward from the top of a building, it's going to make that shape. It's probably going to be, you know, like this, because then it falls down to the ground if you're on top of the building. But it's going to make this shape when you throw it up, and then it comes back down and hits the ground. Alright, so now that we know what it looks like, how do we find the maximum height? Well, isn't this the vertex of the parabola? And height is your y. T in this case is your x. That means we're going to need to find the y coordinate of the vertex if we're looking for the height. But it didn't say what. That's what it says for B part. It says, when does the ball reach maximum height? Well, that's when it gets here, which is at the vertex, and it's the x coordinate of the vertex. You could tell I stumbled a little bit with my words there, huh? Hope you got a little snicker out of that. Alright, so let's look at this. We have x equals negative b over 2a. In this case, b is 80 and a is negative 16. So we have negative b over 2a. That's going to be negative 80 over negative 32, which is a positive number. 80 divided by 32 is 2.5. So what does this mean? This is our x. In this case, it's our t, right? So at time 2.5 seconds, the ball reaches its maximum height. I don't think that part was too bad. What do you think? Alright, look at B part. What is the maximum height of the ball? Well, if we want to find the maximum height, we take our maximum time. What I mean is the time it was when it reached maximum height, and plug it into our formula. So the height at 2.5 seconds is negative 16 times 2.5 squared plus 80 times 2.5 plus 40. Let me just put that into the calculator. I'm going to store that in x and then type in negative 16x squared plus 80x plus 40, and we get 140. So what does that mean? At 2.5 seconds after throwing the ball reached the maximum height of 140 feet. Then it says what or when does the ball hit the ground. I was going to say what time does the ball hit the ground. So it's kind of saying the same thing. When does the ball hit the ground? Well, let's go back and look at the problem. The ball's height above the ground is modeled by this formula. So if this is the height above the ground, when it hits the ground, the height is 0, right? So when it hits the ground, the height is 0. So what we need to do is let the y, or the h, equal 0. Now at this point you can try to factor it, or you can use the quadratic formula. Let's just use the quadratic formula. We have negative b plus or minus the square root of b squared minus 4ac all over to a. (80 squared). Negative times negative is a positive. 4 times 16 times 40 is 2,560. So we end up with the square root of 8,960 over negative 32. Now I don't really have to simplify this because we actually want some values for time. So let's type this into the calculator here. We have negative, parentheses, negative 80 plus the square root, I'll get it right in a minute, the square root of 8960, close the numerator, divided by negative 32. So we get negative 0.46. And we also get all of that with a minus right here, which is 5.46. So what exactly does this mean? This is when the ball hits the ground. Well, go back to the original picture that I kind of sketched up here. If we complete this parabola, the ground is here, right? So we threw the ball from here. Time actually started right there. If we went back in time to finish out the parabola, that would be throwing the ball from the ground. I hope that made sense. So that's why we have negative time, because it's behind us on this building. So we don't really want this negative time. But we do know that about 5.5 seconds after we throw the ball is going to hit the ground, because that's when the height will be 0. So at 5.46 seconds, the ball will hit the ground.